Hello everyone, this is Ali Reza. In this episode, I will do one of the most challenging nodes in the behavior tree. Not as challenging as this sequence node, but it has its own challenges, and that is interrupt. So interrupt is again another one of the decorators. So BT interrupt node schema and BT interrupt node. The node is BT base node and BT base node schema node. Okay, so as you recall, on previous video I showed you a help from Opsiv about interrupt. Now interrupt will have two childs, okay? None of those childs will be multi-connected. So the very first thing we want is to handle that. Let's add our overrides for initialize, and I'm sure that I will have properties. So we will have an outputs.add new output schema. Now outputs of 0 dot multi-connect equals to false, not float, false, and the 1 equals to false. So that's the case for both of them. Let's add our output here too. So override initialize tick, and that's it. So outputs.add new node output. Now output 0 will be the interrupt one. Output 1 will be the actual child one. Let's first, because I forgot how would I draw these guys. I think it will manage it automatically, but interrupt okay, build. I'm thinking about something. I will implement it later on, but it will help a lot when you have this. Now you have two outputs that you need to know if this output is the interrupt or this output is the interrupt. Well, this is output 0, so that is the interrupt, the left one. But I want to give you a visual feedback when you have the mouse over it, a little pop-up that gives you something basically like this, you know, with this start. And when you have your mouse on something, if it's not empty string, then it will show another pop-up with the tooltip. But that's for the end of the chapter, not here. So I will put something here as a to-do. To-do show input output tool tips. Okay, and actually that was in my mind when I was developing this, because if you move your mouse here you won't see the any tooltip, and here you will get a start, but now you can have your inputs and outputs, etc., etc. So now we have two outputs, and question is, what condition should do the interruption? Success of the child or failure of the child? So we will have another enum called interrupt condition. It will have on success and on failure. Okay, so here we will have a serialized field of interrupt condition, calling it condition, and that's it for time being. Now here we will say var interrupt child equals to outputs of 0 dot connection node of 0, and var child equals of outputs of 0 dot connection outputs of 1 dot connection node of 0. Okay, so we need to check all of them. So if outputs dot is null or empty, or outputs of 0 dot connection node that is null or empty. Before that we say or outputs dot, well, count won't be, no, that's not needed because we are not deleting any outputs anywhere. So or outputs of 1 dot connection node that is null or empty. That is when we say our state equals to error and return base static. That's it. So now that we have this, first we need to tick the interrupt child. So we say y interrupt state equals to interrupt child dot tick. Then we say if condition equals to on failure and interrupt state equals to failure, then we want to do the interruption. So I will put here it's interrupt all childs by resetting them recursively. Okay, that needs a method there, you know, very nasty method. But then we need another condition here. So if that's the case, or the condition is on success and we succeeded on the interrupt child. So both of them should do the same stuff. Okay, now other than that, so we didn't interrupt. What if our interrupt state is running, or what if it's errored? Well, if it's errored, if interrupt state equals to errored, we do early exit. So our state equals to interrupt state and we return base dot tick. If interrupt state equals to running, then we say state equals to running, parent graph dot active node equals to interrupt child and return base dot tick. Okay, so we handle the running and error. What if it's other conditions? Well, if it's other conditions means that we don't interrupt anything. We go for the child now. So we say var child state equals the child dot tick, and then uh, if child state equals to error, we do the same error handling, but instead of interrupt child, now we have child state. Not that one, derp, this one. So it's child state. If child state equals to running, then we set this, but the active node is the child now. If child state equals to, well, if it is a success or failure and no interrupt happened, that is when we are setting our state and will return. So state equals to child state and return base static. Okay, so that's it, And now comes to this guy. Now, how should we handle this one? We say child dot interrupt. Now, interrupt actually, instead of calling child, I will call myself as interrupt, and I will go into ET base node and add that. So I will have these are all overrides of the node, Override, 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 yeah. So I will have a method here, and that is public void interrupt. And by doing just this, I will have no errors here. But now here, I will say for each inside our outputs var output, we want to get its connection nodes. So for each output.connection node, we call node.reset. That should be it. Now we say if outputs.is null or empty, simply return. If output.connection node.is null or empty, continue. Let's hope it will work. Let me think. On resets, well, if you look at here, we don't have that. The node itself on reset is setting the state to inactive, is setting the tick to false. That's what I wanted to see. Okay, cool. So we interrupt everything that it was doing. Okay. And what now? Convert to link. Okay. Build. And of course I need now to set these guys property, but condition, the first one is on success, so I can handle that without showing it yet. So I will put a failure as my interrupt. And I will put a flip-flop here. So I will, no, not the flip-flop, no. A counter. How about a counter? Yeah. And I want to count to, I don't know, 20. There we go. So now, if I tick, I keep running the state, okay? But as soon as I flip this guy to success, take a look. Oh. Oh. Interrupt node. Okay. Here's the problem. If the child is not, well, if the child is running, we don't set our parent, set our active node. So reset. Tick, 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 tick. And this guy is getting the active node now. Well, active node equals this now. Well, this is problematic, I know. Build. It's interrupted on success, so why it's not interrupting this guy? It's not interrupting it on anything. So on success and its success, interrupt. Well, for interrupt, we call our own reset first, and then let's see. I said this has its own challenges. This node is not easy one. You should be interrupted right now. You shouldn't even go to this part, you know. Oh, return base .tick. We should return here. We shouldn't tick our child base. How? So it was interrupted, but after interrupt we say state equals to success. So yeah, that's it. So now it's ticking that guy. Now it should interrupt. And there we go. But it's not going up now. So we say parent graph.active node equals to our input 0 dot connection node 0. build. So, and you see that it was resetted. Okay, so it's ticking this guy right now. It should tick it, okay? But the moment it's being negated, why it's not doing that? Why it's not going up? Don't reset ourselves. Just interrupt our children. No, it's not going up. It's not going up anymore. Well, it means that if I, for example, have a sequence here, I'm just trying something to make sure that every child is get resetted. Okay, the counter is not. So it's not recursive. Okay, let's see. We call our interrupt. Okay, do this. Node.interrupt. Interrupt. Why are you not? What? Aha. BT base node. That interrupt. So that would recursively go down the whole chain. So easy. So they are interrupted. But now this guy is not setting the parent as active node. And it should right here. So why? Input 0, connection node 0. Now is time for doing some nasty node finding. Interrupt node, okay? And the active node is interrupt node. Debug.log. That node name before that and then after that. Build. So reset, tick, tick, and I get just one debug message. Interesting. This guy. What am I doing in interrupt again? Build? Why am I not hitting this line? That's bizarre. That's really bizarre, no? Well, let's do this. Nuke that interrupt. Create an interrupt. Hook it again. So reset, tick, tick. There we go. Wow. If you wonder what happened, well, it was just the serialization, nothing else. So there we go. Build and delete. So the very first tick, it will get busy. And by the way, this guy is selected. So we have a busy child, okay? So if I tick it, well, let's reduce this count to, I don't know, 4. Reset and tick. So 1, 2, 3, 4. And it's not going for the child now. Huh. Well, there is a reason. If you remember, on the sequence node, we had this guy. So we say child. Let's move it side by side. So we have a child state, okay? But what is the child? Well, we don't know yet. So we say node child. Then we say if possible child, and that's that. Else this part. Child equals to that. Build. So now if I tick, it should reduce this tick count, okay? So reset, and this guy is on, let's see, 3. So 1, 2, 3, and it's not doing that. Let's delete this guy. 1, 2, 3. No, it's just not going down. Well, it should work, you know. Well, let's remove this part. And let's think about something else. I know that this will lock it and it won't interrupt now. So if I interrupt now, it won't even go up now. Huh. Please counter behave, will you? No, it won't behave. Huh. A very problematic node. So, I don't know. I told you guys this is a very challenging node, and that is the reason. What are we doing? Well, actually, we are here now. Let's comment this part. What? Who? Well, we don't need that part neither. Let's create two successes. That's easier to track. Okay, that part is now working. So yield. Now it's not going up. Are you kidding me? Why are you not going up? Well, this is not the case, you know, it's all here. That part is okay. That part again has nothing to do with us. Parent graph dot active node equals to this build. And although it returns success, it's not going up. It's not setting itself, meaning that we are not setting our state. If child state equals to success, we set our state equals to child state. We set our parent graph dot active node equals to inputs of 0 dot connection node of 0 return base dot tick if it's success, or child state equals to failure, state equals to running, and that. Running, next tick, oh, not that guy, I want this guy. It's still running. The child state BMQ blah. No, 8MQ5. Okay, so this is success. The child state is success. Why don't you reset your success to a success one? Are you still running? Success and tick. Okay, let's see. On top, we say if state equals to success or state equals to failure, parent graph dot active node equals to inputs of 0 dot active node dot connection node 0 return base dot tick build. Now it goes up, okay? But this guy is not returning in proper timing, so that's there. Why are you not behaving? If not interrupt one, I want the child one. If child dot state equals to success or child dot state equals to failure, please do this. But before that, set our state equals to child dot state build. There we go. And we don't need this part, I think. Yep, we don't need that. Okay, so we tick, but we negate now. So what will happen? There we have it. Okay, so that's done, guys. Finally. Now let's see which parts don't we need and which parts need to be uncommented. So first of all, after the error, we check if our child is finished its job. If it's finished its job, then we return up. And well, here's the thing that I'm debating. If the interrupt child was running, what should happen in here? Although that does not make sense. I mean, let's see what will happen if I negate this guy with a flip-flop. Yeah, an interrupt won't happen, okay? So basically interrupt is only interrupting if the interrupt node does return a success or failure. That's the definition of it. So the running state of the interrupt child should be ignored. And we saw that basically it will tick its other child upwards. Okay, so it will tick this guy. Don't forget, it will tick this guy. But as wrong, it will again return running, for example. Then it says, okay, I don't care. The other branch, do your job. If this guy, for whatever reason, for example, let's add another success here so that I get more time. Okay, and let's find that flip-flop one. There we go. So we tick. Now, if I flip this guy now and tick, we get interrupted. So only on success or on fail, we will interrupt the children. Other times, we ignore this guy. That's the definition of interruption. And that's now our interrupt node. Woo, finally. So once again from the code, we have our error state on our output connections. Then we find our interrupt child and our child. Well, let's do this step by step. So we first find our child. If our child was success or failure, we are done. Okay? Or actually, if it's running, or no, sorry, errored. So child state dot state equals to errored. We set our state as the child, and then we set the active node as our parent. We return. If that's not the case, so the child is either running or it's inactive, then we go for interruption. We check the interrupt first. We get the interrupt. We check its state. Okay. If the state is errored, well, we errored up. But if it's not errored, if it's running, we totally ignore it. In the case of success or failure, we check our condition, and depending on that, if we need to interrupt, we interrupt. Remember, we don't reset ourselves, okay? So then we set our state to success. We finished our job, whatever it was. We set our parent, we return. Otherwise, if the interrupt didn't happen, we simply find the child state, and if it's errored, we errored out. If it's success or failure, we will set our state, set the parent, we return. And actually, I think this is redundant now. Let's see. Yeah, that's redundant. Okay. So at the end, if whatever it was, we set our state to running. So we just check if the child did errored or not. Okay. So if it was errored, we error out. Otherwise, we set our state to running. We set our parent graph active node to this, so that the next tick we ticked ourselves, and we return base. The interrupt on BT base node first checks if output is null, return. We don't have anything to do. If it's not null, we check if its connection node is not null. Then in each connection node, we get its node list. We interrupt the node list, so we recursively go down the tree and we reset the node. So effectively, we set it to be inactive and all the index and etc. being resetted. Okay? So everything is interrupted in that branch. And that's it, basically. That's our interrupt node. It was a bit back and forth. I knew it would happen. Unfortunately, well, you have to wait one extra tick. Anyway, that was it was always the case, so I'm not concerned about that. So, wow, I forgot something. We have a condition to create. Wow. Okay, so something that has enum, like parallel maybe, yeah. And I had to select a node instead of. So we have this condition, Control C, Control V, import the namespaces, copy, paste, and the condition, but this is BT interrupt node, and this is only condition. Equals to that. Now the casting is wrong, so I will remove that, and thanks to, oh, come on. Condition equals to pop-up BT interrupt node related node condition. It won't work. Stupid resharper. Okay, so interrupt condition. Happy now? Why are you yelling at me? Ah, make it public. Okay, cool. Did I have it as private? Maybe. I derp sometimes like that. Yeah, I had it as private. Okay, so that's that. Then comes the last part. That is this guy. The easiest part of developing every node. So it is interrupt. So you say interrupt node will tick its interrupting child first at the start of each tick. The child connecting to left output slot. If the interrupting child returns proper state, similar to the one that we set on parameter, then the interrupt node will interrupt all its children recursively downward, reset them, and return success. Otherwise, and what's that wrong with proper? Come on, I know how to spell English, I swear. Are you kidding me? Proper. Okay. Where was I? Otherwise, the error state on interrupting child will cause error state on the interrupt node, and running state on that child will be ignored, and the interrupt node will continue. If interruption by the first child didn't happen, the node will take the second child, the right slot, right output slot, like any normal node, and if by the time the second node returns success or failure, no interruption happened, the interrupt node will set its state to success and will return. Actually, no, not success, to the second child's state and will return. I hope that's descriptive enough. No. We have an error. Okay. Interrupt field color read only equals to something dot color with manifest, and it is interrupt. Build. Final test in Unity. I will delete this, I will delete this, I will create an interrupt. I will hook the right one, and I will add a failure one, why not? So it's interrupting right now on success. Let's do it on failure. So right now, it will immediately interrupt. But now it should tick, and now it should interrupt. There we go. So we got our interrupt node, guys. I could say it was the most challenging node right after the sequence node. I had this much problem and a bit more than this on sequence, and honestly this part came to my mind after debugging the sequence node a lot, and now we have it. So reflection node, compare value, reference, the only nodes that I promised to you guys that I will develop. Reflection node is just bunch of, reflection games. We had seen it by now. Compare value, well, here we will get two values, maybe from properties or from fields, and then compare them. This node will have two objects as serialized fields that are public to you. And again, compare value is one of those nodes that you need to pull the node from the graph, assign the two objects, and then tick the graph and say, hey, compare yourself to each other, And the trick is the comparison there, okay? So reference, I hope it's an easy one. Basically, in reference, you will have a public serialized behavior tree, and when you tick this node, it will get that second tree's active node and tick it, and then return the result upward. It should be fairly straightforward, fairly simple, but for testing it, we need to two different behavior trees actually, and well, you can't track both of them at the same time in the editor window, the work view, but you can track one of them on the basically on the inspector and the other one on the work view. And the send event, receive event, I honestly don't think I can implement them. I honestly don't think, because I have no idea. The problem is here. I have no idea of how to send an event, not executing an event, sending an event from a node to where, I don't know. And how to get receiving messages from an event that, hey, my event is being invoked on what? So I think I will bypass them at least maybe for a day, or maybe right now it's 11 p.m. and I may sit down and read some code to see how can I implement it. I need to watch some YouTube videos, etc., etc. I need to do some research on those two. No promises. It's being bold. It's being capped there for you guys. Sorry. But those three, well, I promised I will do them. And even by these three finished, when these three finished, your behavior tree is much more powerful than behave asset that is on asset store for $200. Trust me. And it's as powerful as behavior designer, that is $65. Not as busy as behavior designer, because behavior designer, you know, added tons of nodes, and most of the nodes are like, you know, can see, can hear, and these are conditions that you could have done in a delegate assigned to the condition node. I just put them as an example on how you can expand this system if you want to, or within distance actually, or random probability. All these four nodes are a condition node, a simple condition node. You know, these guys are simple action nodes that you could have done by delegating the action node. So right now your asset is almost complete. When I add the reflection and reference and compare value, your asset is more rich than the behave 2 that is in asset store, and much easier to be used compared to behave, but not as busy as behavior designer, but as flexible and as powerful as behavior designer. So I hope you enjoyed it. I hope you appreciate my efforts. You have no idea how much R&D I had to do these two, selector and sequence, alone. You had seen the interrupt on the fly today, but interrupt was again easier than the selector. Not selector, sequence. Sequence was the most challenging node for me to implement properly. So until next episode, have fun everyone. Bye bye.